So what I wanted to highlight today is the 4-link system for the Challenger and Charger. I've been talking about this for a while. I've offered it to customers. So today we had the opportunity to set this up so where we'd actually show you and I can explain why you might want this, what it does, how it works, so on and so forth. All right, what's up everybody? So this morning, it's super late, early, whatever you want to call it. It's like 3:10 in the morning. So we actually had this set up. So what I wanted to highlight today is the 4-link system for the Challenger and Charger. It can be any of them, so we basically just do the Hellcat. So I've been talking about this for a while. I've offered it to customers. So today we had the opportunity to set this up so where we'd actually show you and I can explain why you might want this, what it does, how it works, so on and so forth. So what I have laid out here on the floor, so above me is a 2016 Challenger Hellcat. Charger will be the same, it's the same rear subframe. So what we have is a stock rear subframe, and then we have the 4-link system. So I'm gonna show you the differences between the two and try to explain like why you might want this. So the main advantage is gonna be traction, 100%. Most of the newer cars nowadays are independent rear suspension, or IRS. And they do that for a couple reasons. You know, one of the main things, it's a very modular unit, so it's easy to produce the car going down the assembly line. As far as like the most beneficial handling suspension system, it's really not. It's really good if you have a scenario where you need a lot of unsprung weight, okay? And I'm gonna talk about that in a minute. So what that would look like in real life would be like a rally car, okay? So something that's going very fast over very rough terrain. So as far as a road course or a drag strip, we're not gonna have that scenario. So if you went to a track and saw any kind of dedicated road course car or drag car, they would not run an independent rear suspension, they would run a 4-link. So your OE manufacturers, they're drag specific cars. So if it'd be a Dodge, it'd be a drag pack. For Chevrolet, it'd be the Copo Camaro. If it was Ford, it'd be the Cobra Jet Mustang. All those run a straight axle rear end, so like a Ford 9-inch style, okay? And they do that for a specific reason because you can get much more traction out of it, and I'm gonna explain why, and those are set up on a 4-link suspension system. So what we have on the floor here is the stock rear subframe out of a Charger or Challenger, okay, same thing. Now this specific one, it has a 15-inch rear wheel conversion on it. So what that consists of is the different control arms, and the reason you have to do that is two things. You have to get the rear brakes and the rear suspension to fit inside of a 15-inch rim, okay? So I'm gonna talk just a second about why you might want that, okay? So if you're not familiar with that, no big deal. It's real simple concept. If you look at like the drag cars, they will have a real tall tire on it, okay? And a kind of a smaller rim. And if you look at like a lot of the new production vehicles, they'll usually have like a 20-inch rim and kind of a low profile tire. The reason those drag cars run a real tall sidewall tire is because they can lower the air pressure down, and they can put like a B-lock rim on there. And if you look at them in slow motion, you can see it all the time. When they leave the line, the tire wrinkles. Okay, and what that does is the contact patch of the tire grips the track real hard, as long as the track prep is good. And what the tire will do is wrinkle, and it acts like a spring. So it launches the car off the line, and you get a real fast like 60-foot time, a real good track time. If you have a real low profile tire, you're not going to get that sidewall wrinkle. So what's going to happen is the tire is going to be more likely to break loose and spin, and then you're not propelling the car forward, you know, that way. So so a 15-inch wheel, that's why you kind of want the smallest rim compared to tire. So a 15-inch would be ideal. So on this Challenger, the way it came, it had a 15-inch rear wheel conversion. So it has control arms and a brake setup that it will fit inside of a 15-inch rim. On a stock Challenger or Charger, the smallest wheel you can fit on there is a 17, and that has to be the proper wheel with the right offset and everything else. If you don't have it perfect, you can fit an 18-inch wheel. Okay, so on the 4-link system, we can very easily fit a 15-inch wheel with minimal stuff, and I'm going to show you that in a minute. So this is the stock rear subframe, as they call it, and it has the stock coil springs, the stock shocks, and this is all ties into the electronic suspension system. And then what we have is we have the stock differential out of the car. And obviously you all have heard about the horror stories about the rear differential, and we've talked about that on other videos. So I'm going to highlight that a little bit more in this since we have this all out of the vehicle and it's easy to see. So here's the stock system, and what it does is it's independent rear suspension. So what it consists of is a rear end or rear differential, kind of like this. Okay, so it's just kind of like a pumpkin is what they call it. And then it'll have 2 CV axles, which I'm going to just put one of them here just for representation. So you all have probably seen this if you've been underneath the car before. So that kind of goes inside there, and this will go out to the spindle. And so what it does is, you know, the drive shaft hooks to here. This is the rear pumpkin. This is what's prone to braking. The rear axles are CV axles, and then they go out to the wheels. So this is a subframe that houses this, okay? And mainly, you know, the reason that these differentials are prone to braking, it's not the internals that break, it's the aluminum case that breaks. And so what happens is when the torque is coming down the drive shaft, okay, what it is doing is it's transferring the torque to the pinion gear, which is trying to climb the ring gear, and that's inside the differential. So you can probably look on YouTube or something and see a real simplistic explanation of that. But what the gear is doing is trying to climb the ring gear, so it's putting a lot of force and trying to twist this housing this way. And what happens is if you don't have this properly braced, or you have stickier tires in stock, or a track that's got a lot of glue on it, the case is the next thing to break, and that's where you see the catastrophic, you know, explosion videos or the wheel hop or so on and so forth. So the reason why we brace the differentials and we put a different drive shaft and all that stuff is to prevent wheel hop and to prevent those weak points from breaking. So we've got that pretty narrowed down. What we cannot do is we cannot alter the way the torque is distributed from the drive shaft actually to the ground, and that's because of this independent rear suspension. We really don't have any adjustment. So the adjustment that you have is for wheel alignment. So you can get the contact patch of the tire perfectly on the track, but as far as changing the suspension geometry, you cannot, okay? So I'm gonna get into that next, and that is the most important thing on the 4-link. If you have any questions about this stuff, just leave them in the comments and I can try to address specific issues in depth, but I'm just gonna try to run over this as briefly as possible so we get the most, you know, stuff covered. So what we're gonna do on this 4-link is we're gonna remove this rear subframe, and what we wanted to do is come up with a unit where you didn't have to permanently modify the vehicle. So if you look at a stock Copo Camaro or Cobra Jet or Drag Pack, they have a straight axle and a 4-link suspension, and the brackets are welded to the body of the car. Okay, so it's not that it's not reversible, it's just not easily reversible. So if you've got like a Demon of 1 to 3,000 or something like that, you might not want to like weld to the car specifically. You might want the ability to be able to change it back if you wanted to, or if you wanted to sell it and that guy didn't want that. There's multiple reasons why you might not want to commit to that 100%. So what we did is, here's the solution to that, okay? And it is a modular 4-link suspension unit. And what I mean by modular is you can unbolt this rear subframe and you can bolt this in place of the rear subframe, and there's no welding, there's no cutting, no grinding, anything on the body of the car. So this is completely and very easily reversible to 100% stock, okay? So if you had a stock Hellcat or something and you wanted it to have dramatically better track times, but you were worried about, let's say, warranty, and you didn't want to modify the vehicle or tune it or anything like that, this would be a no-brainer, because the biggest problem with these cars is getting adequate traction, and this resolves that problem. So you could run drastically faster track times, whether it be a drag strip or a road course, and I'll get into that in a second, if you upgraded the suspension and increased the traction capabilities of the car. And then you could reverse it if you wanted to. So now that we kind of got that covered, I'm going to talk about this 4-link system, and I'm going to explain it here on this whiteboard. I'm not an artist, but I'm going to do the best that I can. So what we did is, on this 4-link suspension system, we not only wanted to increase traction, but we needed to resolve the weak issues of the rear suspension, like the differential. So basically what you're looking at is a bolt-in 4-link suspension, okay? And what it does is we can take the stock differential and we can bolt it inside the 4-link suspension, okay? So that stays stock. We have a billet rear differential option that we can bolt in place, and we have a full billet forward 9-inch option that we can put in its place and custom do this 4-link system. The full billet forward 9-inch, the main advantage to that over what's on the market now is the differential stays in a stock location, okay? So the biggest problem with the forward 9-inch systems that are out there now is the differential hangs significantly lower. And the problem with that is it changes the axle angle to the differential. It puts the axles at an angle that they become very weak. So if you have an upgraded axle, it's frequent for them to go out basically yearly. So the engineers at Dodge did a really good job as far as like driveline angles, so we wanted to retain that. So what we did is we modified the pinion angle about 1.5 degrees, and we kept the axle angles exactly stock, so it's very durable. And we can run like a 8620 gear set in that, extremely strong. So, but you have versatility. You can stick with a stock one, you can upgrade later on, or whatever you want to do. So as far as the differential, this loads into this assembly, okay? And instead of having a differential brace, what we did is we put mounting pins and everything inside here. And when this differential is loaded inside here, these front bushings, so stock, there's a bolt, this bolt goes in through the bottom and it kind of hangs and mounts, it squeezes at the top. So what we've done here is we sandwich it in between here. And I don't know if you can see it real well, but we've got these locating lugs and everything. So basically what it does is it takes this differential and it clamps it inside this housing. So when the torque comes down the drive shaft, all the torque is distributed inside the differential, which gets transferred to the case. Instead of the case wanting to twist on the subframe, it still wants to do that, but now this thing is bolted and completely encased in this thing, so it transfers the load across this entire unit. So now that stock differential that is a failure-prone part is extremely strong because the actual case itself is doing nothing more than basically holding fluid. It's just a case. So this is highly effective in making the differential stronger than it would be even if you put whatever differential brace or anything you could on that stock subframe. So that in and of itself is a huge advantage. As far as axle goes, the stock CV axles will slide inside these tubes. So the tubes are made where you can use upgraded axles, whether it be from Drive Shaft Shop or G-Force or whatever company that you want. All the axles will fit inside these tubes. So this is kind of like a straight axle, but it's more like a live axle, okay? So it kind of functions in the same way as a stock one, but it has all the straight axle characteristics that we wanted out of the system. So the axles will slide in here to the stock differential, and then at the end you see these billet aluminum housings, okay? So what these do is the stock wheel hubs will bolt to this, and then the stock brake calipers, rotors, and backing plates and e-brakes will bolt to this. So you can reuse all the stock stuff, and if you want to do a 15-inch wheel conversion, whatever, the only thing you need is nothing but the brake caliper adapters, the brake calipers and the rotors, okay? So you're talking barely over $1,500 in parts. We're gonna have this out anyway. We would already have to take the stuff off the car, so minimal labor, and you can either run a 15-inch wheel, a 20-inch wheel, for minimal money, okay? So that is a huge advantage in and of itself. This unit is about 15 to 20 pounds lighter than the stock subframe, so it's not only stronger, but it's lighter, so you're gonna lose a little bit of weight in the back. And then we have these double adjustable coilovers. So this system is gonna come with front and rear double adjustable coilovers. And so I'm not gonna get into all the benefits of that in this video because it's gonna get extremely lengthy. But the main thing I want to point out is we can custom do spring rates. And we have these pretty nailed down to these cars. You have a double adjustable, which means you have an adjustment as far as dampening force when the shock is going down and coming back up, okay? That is critical in drag racing scenarios and road course scenarios. Like I said, maybe I'll do another video on that, but for this video, we're just gonna say that this is highly beneficial and this is equipped with it. One other thing is, a lot of guys like the look of a lowered car, okay? A lowered car at the drag strip is extremely detrimental, okay? And I'm gonna show you that on this whiteboard. So as far as like leaving the line and getting the car as fast as possible, the lower the car, because of the driveline angle changes, it's gonna be much harder for it to get traction. Road course is a little bit different because we're more concerned with cornering and handling. So this setup right here, we have multiple attachment points over here where we can adjust, well, actually mount the coilover at different locations. So we can lower the body of the car or lower the car, and we do not lose suspension travel. Okay, so that is the main issue as far as lowering the car, is we lose suspension travel. So that resolves that, and you have a car that sits at whatever ride height you want. So we got a few adjustment areas. We got the sleeve, we got the mounting point, so on and so forth. Rear sway bar, drastically stronger than that. If you all saw the stock sway bar links on a Hellcat, they're pathetic. It looks like a damn pencil stick. So you can compare that to what we have on here, and the difference is obvious. So now that we've got that covered, I think, let me explain why you would want a 4-link and why it has better traction, okay? And I'm gonna cover some common misconceptions that I hear all the time. So I've drawn this little makeshift diagram here. So let me try to explain this as best and easily as I can. So what we have here is, if you look, the main thing that I want to point out, the most important thing on this 4-link are two things, and it is the upper and lower arms, okay, or suspension arms, control arms. So the upper is going to be right here, okay, and you're going to see this adjustment tab right here. The lower is going to be down here, and you're going to see an adjustment tab right here. So we'll show you that in the video. And I'm going to show you why those are important. And then if you look at the independent rear suspension, you don't have any of that, okay? And that in and of itself is the most important thing that I need to talk about here. So on a stock Corvette, Camaro, Hellcat, it doesn't matter. You hear a lot of people when they say it's at the drag strip or they launch it, and they think that the car squatting is like a good thing, okay? So let me explain what that actually is, okay? So when the car is squatting or the back end of the car goes down, what is actually happening there are the wheels are lifting up into the wheel wells, okay? Obviously, the reason why you would not want that is because the torque coming down the drive shaft is lifting the tires off the road or off the track, which is obviously going to be less traction. What you want is, in an ideal scenario, is you want the tires getting pushed down into the track, okay? And if you look at a drag car, even like a vehicle that would be super light in the back, like a drag truck that has no weight in the back, if you look at those real close, especially on slow-mo videos, you will notice that that truck does not squat, okay? If you look at it really closely, if you notice the back of the truck go down, what's happening is the actual tire underneath the rim is flattening out, okay? The space between the rim and the fender well is actually going up. And what that's doing is the torque's coming down the drive shaft, and it's smashing the tires into the track, and it's pushing the truck down the road, okay? So that concept is extremely important, and that's why these cars have so many traction issues. So I'm going to explain what a 4-link does and why you'd want it, okay? So it's fairly simple, okay? So I'm going to try to break this down very easily. So what I've done here is just kind of drawn a very basic drawing, and again, I'm not an artist, so give me a little bit of break here. But what I've done here is this straight line is going to represent the ground or the track or whatever it might be, okay? This is our rear wheel. This circle right here is going to be the axle or the axle flange, okay? This is obviously the front wheel. So I've got a few things marked here. what I have right here is just basically what's to represent a center line between the axle itself and the ground or the track or whatever the contact patch of the tire is, okay? So this piece right here is all we have to propel this vehicle moving forward, okay? That is it right there. The front wheel, this is the center line of the spindle, okay? And I'll tell you why that's important. This right here, let me explain what this is. So this is going to represent, this is not the scale. I'll just sketch this out real quick on the floor. But this is the center of gravity on the car, okay? And what I mean by center of gravity is if we could attach a cable to the vehicle, okay, and suspend it in midair, it would be the point of the vehicle that is attached where it would be completely balanced in the air, okay? So roughly where that would be, we all know that the front of the vehicle is heavier than the back because the engine's up there. It's going to be at a certain space back and a certain space up, okay? So the way to get the center of gravity, I'm not going to get into detail, but you would basically put scales underneath the vehicle. You would weigh it front to back. You would figure out the percentage of weight to the front to the back, and that would give you this spot from front to back that this is. And then there's a different procedure that I'm not going to get into that would give you the height. So for this scenario, I'm going to say that basically the general rule of thumb is the back of the camshaft. Okay, so the camshaft at the back of the engine block is pretty close to the center of gravity. Okay, now this is probably not the scale, but I'm just going to use this for a scenario. So say we attached a cable right here and this vehicle is suspended in the air. That means it would be perfectly balanced. So the same amount of space between the wheels and the ground would be the back and the front. And if I push down on the back, the front would come up, and if I put the same amount of force on the front, the back would come up, okay? So the reason why this is important and the center line of the front spindle is important is because this is where we get this, the anti-squat line, okay? So this is very basic geometry, okay? So it might sound a little confusing, but it's really not. So what we have is all we're looking at is a triangle here, okay? So the ground is one side of the triangle, the anti-squat side is the second side of the triangle, and here we have the third side. So what we're coming up with, the reason why we want to find this stuff is to find the anti-squat line. So the anti-squat line starts at directly underneath the center line of the axle where it touches the ground, and where it is going to intersect between the center of gravity of the vehicle and pass through the center line of the front hub, okay? And the reason why this is important is it's very simple, is because the torque coming down the drive shaft is coming down to the rear wheels, okay? And we're going to propel the vehicle going forward, okay? So this anti-squat line, if the torque is applied underneath this anti-squat line, what's going to happen is the same scenario that's on a stock Hellcat or any other car with independent rear suspension. It is going to try to, if we push the force here, okay, down on this line, the front of this is going to come up. Oh, so a wheelie, which is cool and all, but it doesn't make the car go down the track. So when we have the front of the car goes up, the back of the car goes down, and that's the squat that everybody's concerned with. And what's actually happening is the torque is taking the wheel and pushing the wheel up, okay, which is making the back bumper go down. It's lifting the car up, okay. So what we want to do is we want the car going this way. We don't want it going this way, okay. So whatever energy is used to pick the front of the car up, it's not putting the car forward, okay. So what we want to do is get as much force going forward as possible. So on an independent rear suspension, we have no adjustment over any of this. We're just stuck with what it is, and we have no control over it. On a 4-link system, we have infinite adjustability of this if it's designed right. So the system we have is extremely effective at this. So the one thing that I'm going to highlight is I talked about the upper and the lower arm on this 4-link system, okay? And the stock system doesn't have any of that. So the reason why I highlighted that is because this right here. So I'm going to make just a couple just real quick lines, okay? It's not going to be real important. You're going to get the point real quick. Okay, what I've done is I've just drawn a line at the top and bottom, and this is to represent this upper arm and this lower arm, okay? So the this is going to kind of be realistic to what they look like if you could look at the side profile of the vehicle and see them in relative space. And so both of these arms, you notice on the 4-link, we can move them up and down and change them. So if you took these two lines and you kept them going infinite space, there's going to be an intersection point between these two lines. Okay, whatever that whatever that intersection point, it's called instant center. Okay, the reason why that's important is because we want to know whether it is above the anti-squat line or below the anti-squat line. Okay, if it is below the anti-squat line, we're going to have that scenario where the front of the car lifts up, the back of the car goes down, and it's lifting the tires off the road or off the track. That's not what we want. What we want is this instant center above the anti-squat line. So what this looks like in real life is a drag car, okay? The truck that has no weight in the back and it's super light, and when it hits leaving the line, the back of the truck's not going down, it's smashing the wheels into the pavement, okay? So you get the maximum amount of traction. It's doing the opposite of a stock Hellcat. The reason being is because now with these arms, when the torque is coming down the drive shaft, okay, and the pinion gear is trying to climb the ring gear, it's transferring the load right here to these arms. And this is above the anti-squat line. So what's happening is the force of the engine is pushing down on this, okay? So it's trying to force the front of the vehicle down, and it's trying to force the back bumper up because it's pushing the wheels into the track, okay? The harder it pushes the wheels into the track, the more traction you get. It's also pushing up on the back bumper and down on the front, so it's trying to resist a wheelie, okay? The more it does that, the more the vehicle can go forward instead of using energy to push the vehicle up, okay? So that is the basic principle behind this. There's a lot of other variables that I'm not going to get into, kind of like where this intersection point is, you know, the higher the power of the vehicle. You know, where this instant center is, you can move it toward the engine or toward the rear end to make the transfer of torque faster or slower. You know, you don't want to push the tire too hard into the track, and you don't want it to be too little. So you can change this angle and change that by going forward and backward on the anti-squat line. If you got a road course car, say you like to go to a road course, this is also beneficial, because what you can do is when you're going around a hard corner and the car is going to be real apt to the back end going to come out from underneath it, so you have to be real easy on the gas. Well, on like a stock independent rear suspension, the more torque you apply or the more gas that you apply, it's wanting to lift the wheels off the track, so it's going to make the rear end come out from underneath it. If you have a 4-link like a traditional track car, the more torque you apply down the drive shaft, or the more, you know, throttle you give the car, the harder it pushes the tires into the track. So if you're going a real hard corner, what you can do is, instead of like coming off the gas a lot so it doesn't slide, you can apply more gas, more throttle, more torque, and it's going to keep pushing the tire harder into the track, so you can go around the corner much faster. So it's beneficial. So that's kind of like the principle behind this. So that is why like a drag pack car, a Copo car, a Cobra Jet car look like a stock car, and power-wise they're the same, sometimes less power, but they're significantly faster at the track. And there's a few reasons for that I'm not going to get into, but one of the main reasons is the straight axle or 4-link rear suspension that's under the cars. Every single one of them had the same thing. So this is our way of duplicating that in a very user-friendly manner that we can use a lot of the stock components. It's completely reversible. No, like I said, no permanent modifications to the car, and it just flat out works. So if you're used to driving a Hellcat, you get very used to when the back of the car is going to come out from behind you. The test vehicle is a little bit weird because I get so used to it. It was weird because I could apply more throttle and I got more traction. So what you can expect from this system is pretty much on a stock Red Eye or Demon, you can easily hit 0.9 to 1.160 foot times. So if you're familiar with track times for a Red Eye or a Demon, to get anything, you know, 1.3, 1.4 is really, really good. To get sub 1 second is unheard of. Okay, so it's because the suspension of the vehicle, not the added power. So what you can do is run a much faster track time with way less power. And so it works. You know, if you have any questions about this, you know, this system is around, it's around 12 grand for the system if you get with the double adjustable front and rear coilovers. But if you're getting one of our packages, some things that you don't need are like the rear, you know, no rear control arms. You don't need any differential bracing because everything is completely handled with this. So you can upgrade a differential if you want to, but the stock differential is good for a lot of power. We don't usually upgrade them. Same thing with axles. Now the wheel hop is basically not an issue, so we've got that covered. So the stock axles are extremely strong. So this is the most ideal solution to making the car as bulletproof as possible. You can expand on the system, so if you want to add axles later, no big deal. You can do it very easily. And getting the absolute most amount of traction out of these cars as possible, which is the easiest thing you can do to make them faster, okay? So if you have any questions, you can leave them in the comments. For anybody that's interested in the package, what we do, I wrote an entire 4-link Word document that I can send people, and it kind of explains this, but I think it's probably a little bit helpful to see this because I think this would be kind of hard to visualize, where if you can kind of see it, it makes more sense. So if you look at this, watch this video, we'll link it on our new website that's getting ready to launch the end of June, and then along with the document, I think it'll make more sense and why you might want it. So that's pretty much it. See you guys next time.